this module, you'll learn the power rule, which is a fantastic shortcut for finding derivatives. But to really appreciate it, first you have to see just how difficult derivative finding is without the power rule. So, as I said in the last module, you can find derivatives using the difference quotient. Let's go ahead and do that. We're going to find the derivative of f of x equals x squared using the difference quotient. So I should plug x plus delta x into the function x squared, and then to subtract x plugged into x squared. So let me do that. Now we need to simplify. To simplify this, I'm going to go ahead and square both terms, and I'll get x squared plus 2x delta x plus delta x squared minus x squared all over delta x. You can see why the difference quotient is a little complicated. We've got a lot going on here. So let's go ahead and cancel those x squared terms out. And now we're going to use the factoring method to evaluate this limit. In other words, we're going to factor out a delta x in the numerator, and then cancel it with the delta x that's already in the denominator. We can now plug in 0 for delta x to get the limit, and our derivative answer that we've been looking for the whole time. The answer is 2x. So in other words, the derivative of f of x equals x squared is f prime of x equals 2x, according to the difference quotient. There has got to be a better way than this. And there is. The power rule. And since you've seen the ugly way to get the derivative, you'll appreciate the easy way even more. As I said before, the power rule is a shortcut for finding very simple derivatives. If you've got a variable being raised to a power, then you can use the power rule to find its derivative. I'll show you how to do it with x squared, since that's the derivative we just found a second ago. There's two steps we need to follow here. First, pull a copy of the power down in front of the term. So in x squared, we're going to pull that power of 2 down in front. Next, subtract 1 from the exponent. Here, my exponent was 2, so I'll subtract 1 from it. 2 minus 1 is 1. And that's all there is to the power rule. The derivative of x squared is 2 times x. Remember, we don't have to write the 1 power, because if there's no power written, it's understood to be 1. Can you see why this is so much easier than the difference quotient? It even works if the term you're differentiating has a coefficient to it. For example, let's derive g of x equals 3x to the 7th power. Before we apply the power rule, we'll just scooch the 3 over a little bit to make some room. Now, all we have to do is pull a copy of that 7 power down in front, subtract 1 from it, and we have 3 times 7x to the 6th power. To finish, multiply 3 times 7 together, and get 21. One of the most powerful and one of the most basic rules of calculus. The power rule is great.